My name is Mike Friedman. Some of you may be familiar with me. I'm also called Friedo on the internet. I work for a little company called MongoDB. And up until just a little while ago, we were called 10gen, the MongoDB company. But whereas people have heard of MongoDB, nobody knows what the hell 10gen is. So as of August 27th, we are no longer 10gen, and we are now MongoDB. So to clarify this, I work for MongoDB Incorporated. Their primary product is the open source document database called MongoDB. They employ me, Mike Friedman, otherwise known as Friedo, and my job, among other things, is to work on the Perl libraries for talking to MongoDB, which is a CPAN distribution called MongoDB. So to clarify all of this, if you want to use MongoDB, which is published by MongoDB, you have to use MongoDB, which is published by MongoDB, to talk to MongoDB. So I hope that clarifies it. Who here has actually used MongoDB? You just played around with it, or you use it in your job? That's really right. So the initial version of this driver library, by the way, before I took it over, was actually written by Florian, but I don't see him here, I guess. No, I saw him yesterday, but he's around somewhere. So, yeah, so all the stuff that you might not like about the driver, you can blame on him. All right. So, well, what actually is MongoDB? It's all of these things, and all of these fast buzzwords, but the most important one, I think, is this one, document-oriented. And a document is basically a JSON-like thingy. So anything that you can express in JavaScript object notation, you can sort of exist as a first-class citizen in MongoDB. And we actually use a superset of JSON that has supports for some more interesting types. But everything you see here, every key value array and subdocument and so on, are first-class objects. They can be indexed, they can be queried. Anything that you can do to first-class objects in other database systems, like relational database systems, you can do to all of those things in MongoDB, which makes it kind of really interesting to work with and to see what you can do. So the title of this talk is Testing CPAN in the 21st Century. Or it might be 21st Century CPAN Testing. I keep going back and forth with this. But this talk and the project it's about was inspired by what I like to call a lengthy series of bad ideas and stupid questions. And there's a bit of history. I've seen Stephen's talk on the Perl 5 mob twice now. I saw it a couple weeks ago at the New York Perl meetup, and I played it yesterday. And he always talks about the problem of sort of throwing the first prototype away. And this is a project that I've sort of gone back and forth on. I've thrown away, about 4 or 5 prototypes of different pieces of it. So this is kind of like my version of Perl 6. And so, stupid question number 1. This is a question for the audience. How many people here use CPAN? I would be shocked if anybody did not raise their hand. So I'm glad that pretty much everybody did. And what about this one? Who here is a CPAN author? That's a good percentage. All right, I like to see that. So this talk is about this project that I started working on a little more than a year ago called CPANci. And to understand the impetus for this, I want to take a brief detour into a little bit of history. So who knows what this date is? December 18th, 1987. Anybody have a guess?
Perl 1.0.
Perl 1.0 is exactly right. So Perl 1.0 was released on December 18th, 1987. And this was also when this cool thing called TAP was released. And TAP was originally designed as the output format for the test suite for the Perl 1 compiler. It stands for the Test Anything protocol. And the idea is really simple. You've all seen this when you install modules. You get this thing that outputs some numbers and some OKs or not OKs, and maybe it comes from the test suite, maybe you just have a script that spits out OK. In any case, that's TAP, and it's really simple and it's really straightforward, and it's endured for several decades. So October 17th, 1994, Perl 5, you are correct. So that is Perl 5.0, and this is the first time when Perl really had a module system. Perl 4 had require, you would require scripts, but we didn't really have modules and namespaces. So we sort of transitioned from this to this. Of course, but under the hood, it's really that. But the lesson is that this was the first time when Perl was really extensible. You had namespaces, you could import functions, you had things like prototypes, which came a little bit later in order to emulate built-ins and things like that. And this was the point when Perl transitioned from an isolated sysadmin language to an extensible general-purpose programming language that could be made to do really anything that you set your mind to. Here's another one, October 26, 1995. This is when CPAN was established. And I'm not sure exactly what counts as the establishment of CPAN. I think I got this from a Wikipedia article or something. But this is when Perl modules soon became available to everybody. It's one, lots of programming languages have had namespace and module systems, but Perl was the first one that really had a successful centralized repository where everybody could put their modular code and everybody could get it. And this goes back to 1995. CPAN is old enough to have children, a lot of them. And it's kind of surprising when you consider that a lot of other languages out there have only really caught on to this idea in the last 5 years or so. Here's another interesting one, May 15th, 1997. This was Perl 5.004, which would otherwise be a fairly unremarkable release, except for one thing. CPAN.pm is in the core. So at this point, in 1997, just a little more than a year after CPAN was established, everybody who has Perl now has a way to access this repository in an automated fashion and install the code from that. So back then, we had to do this incantation. Now it's a lot easier, especially with things like CPAN-, which I really like. May of 1998, CPAN Testers was conceived, and this was a system that provided automated feedback for module authors to find out if their modules were working. And those of you who raised your hands and said you were CPAN authors have probably gotten this, the fail mail. And I get a lot of these. They're always distressing. And so November 15th, 2003, this is Perl 5.6.2. We're still in ancient history. So we're in Perl 5.6, which is an ancient release, but this has test more in the core. And I don't have any scientific or statistical proof of this, but I have a suspicion that test more is probably one of the most widely used unit testing libraries in the world. It's that ubiquitous, because it's not just CPAN. There's huge numbers of organizations that use this as just a very simple, very basic testing framework, because it's just so easy to set up and use. And if you've never seen a Perl unit test script that uses test more, it's very simple. You just tell it how many tests you have, and you make these assertions, and it spits out tag, that okay, not okay stuff that you saw before. This is a really hard one, August 6, 2012. Anybody know that? I'd be really impressed if you did. So August 6, 2012 is when I started my job at Friedman. Excuse me, MongoDB. So that led to the bad idea number one in this lengthy series of bad ideas. I said, shortly after I started this job, I said, I need to come up with something cool to show off at YAPC. And I actually started, in August in 2012, so shortly after YAPC, I think that was the YAPC Madison. So I had to come up with something to show off. And what I ended up thinking about as I took over maintenance of the Perl driver for MongoDB and started fixing bugs and causing bugs was I would get these reports from CPAN testers, and some of them were useful and some of them were less than useful. And CPAN Testers is a really cool and amazing thing. And we consider how long it's been around, how many test reports it's generated, and how useful it is, because it is often very useful. It's fantastic that we have something like this, but there are caveats, there are some disadvantages. One disadvantage is CPAN Testers is not in real time. You have to wait to get the data back from CPAN Testers. You upload a module. Some people will download it right away and submit test reports. Some people will download it months or years. Some people will download the thing 6 releases ago for some reason and submit test reports on that. It's not consistent. And what I mean by that is not that you're not always going to get results, because you will always get results eventually, but that the same guy who tested your release last time might not test your new release this time. And what if that guy had something weird about his environment? He was running on a weird OS that you wanted to test against. He was running on some weird hardware. Well, you could try emailing that guy to see if he'd be willing to submit again, but in general, you're sort of at the whim of the crowd to figure out what you're going to get. And it really only works because of the law of large numbers. Chances are good that you're going to get a test report on the Perl version, on the OS, on the hardware you're interested in, as long as that is not something really, absolutely strange, like OS2 on a Metro card machine or something. Here's a big problem. Polluted and inconsistent environments. A lot of those failure messages that you get are a result of nothing wrong with your code, but a result of something wrong with the box that it's being tested on. They've done something really weird to their Perl environment. They have locally patched modules, which are being brought in as dependencies for your distribution and causing a bug, which is not actually a bug because they did something. They have non-standard versions of certain utilities or libraries. They have, their disk is full. And you run a test suite and the disk is full, well, guess what? That's going to cause a bunch of errors, even though there's nothing wrong with your code. And I've seen cases of people, with smokers that have disks full for a week. And to their credit, CPAN Testers often detects that sort of stuff and will remove people from the testing pool if that sort of thing isn't corrected. But until that happens, you still get those fail mails. And you can get a wide distribution of versions and platforms and OSs through CPAN Testers, but you're never quite sure what you're going to get. I actually, just last night, I looked at the CPAN Testers website to see some stuff. I found Perl 5.18 is running on GNU Herd. Who the hell is using GNU Herd? I honestly have no idea. I'm wondering if, like, Richard Stallman is a CPAN tester. I doubt it, but I don't know. And the thing about GNU Herd and, OS2 on Metro card machines and QNX and all this stuff is, I really don't care. I don't care if I get test results back from these weird OSs. And I know that some people do, and everybody has different priorities. But I have 24 hours in a day, and here's what I have to care about in those 24 hours. I have to care about Linux, I have to care about Mac OS, and I have to care about Windows, just because I don't want to, but I have to. But those are the big three for me. And really, I would like to even declare that only 64-bit. That would be my preference, but reality doesn't work that way. But these are basically the big three operating systems that I need to care about and that I need immediate feedback for. And I can't always get it through a decentralized push-based system like CPAN Testers. What I wanted is continuous integration testing for the entire CPAN. Now, I did this because I wanted it for my modules, but if it would work for my modules, it would work for everybody. So, and the corollary to this is I want this for platforms I care about. And the reason that corollary is necessary is because if you try to set something like this up for every platform that CPAN Testers is on, you would never get it done. So bad idea number 2. I registered a domain there. And there it is. There's nothing there right now because I broke it. There will be some, I'll talk more about that. So, stupid question number 3, and this is really a rhetorical question, is how can we test CPAN without the disadvantages of CPAN testers? And the goal here is not to make CPAN testers go away, but to augment it with something that is also helpful. And I thought about this for a long time. And I came up with kind of a premise for doing this, a postulate. And I said every CPAN distribution must be tested in isolation on a virgin Perl installation untouched by human hands. So that was my postulate, and I want to demonstrate for you why this is true. Let's suppose I release a new distribution. Here it is, foo awesome. And in my foo awesome code, I use this module, but for some reason, maybe I'm lazy, maybe I'm stupid, I don't use one of those many automated tools for managing my dependencies, and I forget to list this dependency in the distribution metadata. What happens when this goes out to CPAN testers? Well, there are a few things that can happen. Here's one scenario. Let's suppose that the tester does not have this dependency, this spiffy module. So he's going to, run his test machine and test around, and sure enough, it explodes. And it errors. And I get the fail mail. Fail mail. All right, so that's fine. That's useful feedback. What about scenario 2? Scenario 2, in this case, the tester already has that dependency module on the system. What happens? Anybody know?
Yeah.
Test pass, because there's no error, right? He already has that module. You say use spiffy module, it loads right up. Nothing wrong. Everything is fine. Everything is not fine. This is a false positive. This is actually really, really bad. This is worse than a false negative from a broken environment. You're getting feedback now saying that your distribution is working absolutely fine when in fact it's horribly broken. And of course you will get test failures down the line at some point. At some point some tester who does not have that dependency installed is going to get it and send you a failure report, but you might not get that right away. It might be days or even weeks. So this is one of the serious disadvantages because with the way the testing ecosystem is set up right now is you cannot test dependency resolution in an isolated way. So that brings us back to our postulate. Every CPAN distribution must be tested in isolation on a virgin Perl installation untouched by human hands. So how do we actually do that? Well, I started thinking about what tools were available to me, and there are a few tools that are available now that were not really available when CPAN Testers was first set up. One of which is Perl Brew. I love Perl Brew so much. Raise your hand if you use Perl Brew. You guys are super awesome, and I love you all. So a second tool, virtualization. We now have the ability, to various services out there, EC2, Linode, all those sorts of things. You can just spin up instances and do stuff and then shut them down. You can start virtual machines at the drop of a hat. So this led to bad idea number 3, which was the first prototype since thrown away. We'll soon find out why. And it worked like this. I said, all right, I'm going to create an EC2 image, and I'm going to put Perl Brew on that image. And I'm going to use Perl Brew to install every version of Perl that I'm interested in, from 5.8 to 5.18. And every time a distribution is uploaded to CPAN, I'm going to boot an instance of this image. And every time I boot an instance, I'm going to grab that particular distribution that was uploaded, and I'm going to install it and any needed dependencies on this fresh EC2 image. And I'm going to run the tests, I'm going to report the results, I'm going to store them somewhere, and then when it's all done, shut down the instance. And I worked on this for a bit, and I got it working. And it was actually doing something. I was like, yeah, this is really cool. This is actually useful. And then I got this bit of fail mail.
Oh.
And so, all right, so I thought, all right, maybe that's not a great idea.
How much did it cost?
The first month I had it running, I spent something like $280. So that was not sustainable. I also learned a lesson about, maybe checking my Amazon usage more frequently than every month when I get the bill. So stupid question number 4, how do we do this on one instance? So I thought about, all right, what are other tools that we have available that maybe were not available in the past? These two tools are really cool, local lib and CPAN-. And I really like CPAN-. And you know, I've been hacking Perl for a long time, and I remember, you know, having to set up the old CPAN.pm, and you know, you have to go through and answer 50,000 questions and pick out mirrors, and you know, God help you if your network wasn't set up for FTP. It was a mess. So CPAN- makes this a lot really easy, and one of the things that makes it really useful for this project is that it's self-contained. CPAN-m is built with FatPack, which basically takes it and its scripts, shoves them all into one file, and there's no, it's all pure Perl. So you basically have a single pure Perl file that implements this entire application. What that means is that I can have a single CPAN-m somewhere, and I can use any Perl binary to run it and install modules. So let me show you what I mean. All right, I've got Perl brew here with a bunch of Perls installed. And I can use this Perl called master, which I think when I set this up was maybe a 516. And I can use that to install CPAN-m, symlink the CPAN-m script to just in the root of my home directory. And now I can use that CPAN-m by invoking any one of these 10 Perls that I have installed. And CPAN-m will then be loaded in the context of that Perl and install modules in that Perl's ecosystem. Very simple. So here's my new plan. I'm going to use Perl brew to install that master Perl that I just showed you. And I'll use it again to install virgin Perls of every major version I was interested in. In the current box that I have this set up on, I think it's something like 40 versions, basically every major of my included development releases. And that's not all of them, that's going back to like 5 to 8 something. And I probably forgot a couple in there. So, and then to actually run this, we use that master Perl to install everything that makes the system work. So for example, we're going to store test data in MongoDB. The MongoDB driver is built on Goose. It has a bunch of dependencies that would pollute the environment if we use that as our testing environment. So we'll install that MongoDB driver and the other stuff we need in this master Perl brew installation, leaving the other ones untouched. So for every distribution that's uploaded to CPAN, here's all we have to do. Create a temp directory. This is where everything's going to go. And we'll tell CPAN- to download that distribution and install its dependencies in that temp directory as if we were using local lib. And this is kind of the hack of it. And we'll see how this actually works in code in just a second. So then we run the tests and report the results, delete the temp directory, and all of our virgin Perl installations are left untouched. Never touched by human hands, as if they had just been installed. So what does this actually look like? So here's some actual code that's running right now that makes this thing work. So the first thing we do is we hit the meta CPAN RSS feed, which just has a fairly close to real-time list of distributions that are uploaded. I think when I upload something through Diesel release, it shows up in that RSS feed like 1 or 2 minutes later, sometimes sooner than that. So all this does is it just uses LWT user agent to grab that RSS feed and parse it into an XML object. And what we're going to do is basically find all of the RDF nodes in this RSS file, and we're going to take each URL. The URLs in this RSS file point to the distribution page on metacpan.org. So we're just going to lunge that URL a bit, change the host to api.metacpan.org, change the path a little bit, return that URL, and what we get is an array consisting of URLs pointing to each distribution's metadata page on the MetaCPAN API, which just returns a gigantic JSON structure of all the interesting metadata for that distribution. So what do we do with that? Well, we're going to loop over that array of distribution URLs, and then we fetch the actual metadata. And so again, the dist here is a URL, so we just grab it. What we get is JSON, and we create this hash, which is going to be the document that we're going to insert in MongoDB. So a few things you need to know. In MongoDB, every document that you insert in a collection has to have a primary key. It's always called _ID. And there's an automatic index on that and an automatic unique constraint. So what I do, if you don't set underscore ID, a number will be assigned automatically for it. It's a special object called object ID, but you don't need to know that. So all I do is I just set the primary key for this object to be the string CPAN/ and the name of the distribution. The name of that distribution will be basically the name of the tar volume, so like foo-bar, dash, and a version number. And I keep track of when it was fetched, which is just a timestamp. And then that meta field is just the big JSON object that we decoded from the API. And there's actually a lot of data in there. And then to store that in the database, you just do this. Now, this is not like storing an opaque blob of JSON text in a relational database field. Because remember, MongoDB is a structured document store. So all of those fields, everything that we grab from the API, those are all first-class objects that are queryable and indexable in MongoDB. All right, so here's where stuff starts to actually get interesting. So in this object, I have a list of all the Perls we have installed. So we're just going to loop over it. And what we're going to do is we're going to, some code is omitted here, but basically we're going to construct a directory, a temporary directory for where we're going to do this, which is basically the directory work / the Perl version that we're testing right now and the distribution name. And we're going to create that, and create the directory that is omitted here, change into that work directory. So now we actually have to run this particular Perl against some of the code. So this just defines a variable called PL-bin, which is the actual Perl binary that we want to run. And so that would be basically the name of our Perl installation /bin/Perl. That's where it is. And then to run it, here I just use open3, so I can attach handles to standard in, standard out, standard error. And so what we're doing is we call that PL-bin file. The arguments are the path to CPAN-m. So we're running CPAN-m in the context of a particular Perl installation. And we tell CPAN-m to install deps, which will install the dependencies of a module that we have in the file system. We tell it not to test because I don't want to recursively test all the dependencies. I just want to make sure I can install them. I'm only testing the distribution that I downloaded. And there's this -L flag. And this one is particularly interesting. This is an option to CPAN-m that says install it in a local lib, which I specify. Now we're not actually using local lib here, but we're just telling CPAN-m to use this temporary directory as if it were a local lib installation. And CPAN-m will happily do that. So we do all of that, and then we read the standard error output from this because CPAN-m dumps its logging information on standard error. And I actually have kind of an interesting chunk of code that parses that log. And I don't have a slide of that though, but the result is you end up with a structure like this. This is in JSON format, but this is basically, if you've used CPAN-m, you recognize this as all the stuff that it spits out. But what I've done here is I basically transformed every line that CPAN-m spits out into a little JSON document in this array called a log. And the lines contain all the status of the dependencies that we had to download in order to test this module. And we even include the indent number, so when we print it out, we can make it nice and indented. So how do we actually run the tests? This is where it gets really fun. So I have this array called @tests. Basically, this just comes from a simple blob looking, for star.t in the distribution directory. That isn't perfect because there are some tests in the T directory that might be named .pl or something like that, but this is correct in 99% of cases. So again, we're just going to get the particular Perl version that we want to run these tests against. And in order for Perl to find the module, the distribution, and the dependencies that we installed, we need to tell it to look in that temporary directory for modules to load. And we do that here using the -I flag. And you could use local lib on the command line to do this as well. I just used -I because it's less technical, I guess. So all we do, this is basically the equivalent of just saying Perl t/foo.t to run a test And all we're doing here is we're saying use the specific Perl and use the specific directory to find modules for it. And then all I do is just in select mode, I grab everything that came out on standard out and everything that came out on standard error. If everything worked, we'll get tap on standard out and any warnings or errors that might occur on standard error. Wait for that to finish, and then to determine if the test file as a whole succeeded, just test the exit value. If it's 0, then the test file as a whole succeeded. If it's not 0, then something in that test file died. So that gives us information about the test file as a whole, but what about the individual tests? A test file might spit out 14,000 tap results, if you're sitting on the side of the room. Or it might spit out something less than that. So there's this nifty module called tap parser, and as you might expect, it's for parsing tap data, and it works really well. So you just give it a source here, this tap output that we got from our Perl process, and this gives you an iterator, so you can loop over all those parser things. And we push this ugly kind of structure onto an array called test results. So the first thing in here is this is the actual text, the actual line of tap data that was printed out. We want to keep that around, so we store that. The second thing is if this line was an OK. So if it was a test that outputted OK, we'll store a true value there, otherwise a false. Those are the true and false constants from Google. There's a type line. So tap has, I think, 4 different types of things that can output. So one is a test line, which will be OK or not OK. One is the plan, which are the numbers at the top. You see like 1 to 42. Other things are like tap comments and some other stuff. So that gets stored at the type. And then if the type is an actual test, I also store the number of that test, because every test has an inordinate number. And the description of that test, which is the optional data that was printed after the OK or not OK. And then if it's not a test, I ignore those 2. So the test results array is populated with all of that data. So what does that look like? Well, it looks like this. And that can go on and on and on and on. So this is JSON. We can store this in MongoDB. Every one of those fields and every one of those subdocuments is a first-class queryable object. And it's also a tap. And this is what's really cool about this. So it doesn't look like tap, but it's got all the tap data right there, which means anything, any kind of analytics or aggregations that you were doing with tap data, you can do against this data using a database engine rather than writing all the code yourself in Perl. So what does that mean? Well, you can take all of that data and you can create beautiful tables. And I had a prototype version of a website that showed off some of this data. That's part of what I showed off at Yapsy. It was very ugly, it did not work very well. I am happy to announce that I've almost completed the new version of that website, which will show these beautiful tables on CPANci.org. And the announcement when that goes live will be in probably a couple of days, as soon as I finish the blog post for it. And you can all check that out when it's ready. So I want to end this with some final thoughts. And you know, this was a really fun project. I enjoyed working on this a lot. It gave me a chance to play with new toys, which is something you should always do. Whether it's new CPAN modules, new programming languages you haven't tried before, new database technologies you haven't tried before, give it a shot, because it's always a learning experience. And more importantly, it teaches you how to think in a different way. Working with MongoDB is actually kind of frustrating at first, because if you come from a relational database world, as I do, it's actually difficult to train your brain to think in a non-relational context about data. But once you do that, you start to realize that relational databases are not the greatest answer for every single problem. They're great for some things, but not for a lot of things.
Heresy. Relational databases cured my sciatica.
I'm sure they did, but they can't cure everything.
Relational databases sealed my basement.
Yep. Think before you code. This is a lesson that I have learned repeatedly over the course of my career. Writing code is fun. thinking is not always fun, because thinking generally involves you sort of sitting at your desk, staring off into space, and then your boss walks by and says, what are you doing, daydreaming? You should be writing code. But thinking before you code is very useful, because it often ends up allowing you to avoid making some of the mistakes. And you're still going to make mistakes. You're still going to throw away prototypes that don't really work. That's fine. But you can save yourself a little bit of time just by putting in some thought before you satisfy the urge to just jump right in. Throw stuff away. This is a lesson that I've also learned. It's probably going to be sucky the first time you do it, especially if you don't know what you're doing, which I rarely do. So these are the most important ones. Have bad ideas, ask stupid questions, and have fun. These are the ways that you learn new things. These are the ways that you do incredible stuff. And if you do these and apply these lessons, you will accomplish cool stuff. So if anybody has some perhaps not stupid questions, I'd be happy to take them. Yeah.
Yes. How would you test an XS model? Do you synthesis and do that with the compiler?
So in XS module, there are a couple things to keep in mind. One is that if you can download this XS module from CPAN-M and install dependencies, assuming you've got a compiler set up and so forth, then it'll work fine. All that stuff gets stored in the temp directory. It all gets compiled in the temp build directory. I didn't talk about the build directory, but it's a separate temp directory, and it gets installed just fine. That's assuming you've got the compiler installed and the libraries that are needed if this XS module is linking to external libraries. In the case where there are external C libraries that are needed, there's really no good answer to that right now in Perl. There just isn't. There's some folks have done some great work on Alien Base, but it's not really there yet. So if you have an XS module that links to some library that has to be installed, there's no way to automate that right now. You just have to say, you have to install this from your package manager. And in that case, in this system, the test will fail. And that's sucky, but I don't have a good answer for it, unfortunately.
I have a module that uses graph.pm, and it had been up on CPAN for a while, and suddenly I had this weird fail for one person, and after digging, I discovered that they had changed the API of graph.pm quite a bit,
Yep.
and I had to add a dependency, and if I had just said graph.pm and everyone was running a version install, I would have never caught that error, and I would have never known that I had to put a version dependency.
Was that an error, or was that a result of the dependency changing?
I just had a dependency for graph.pm, but I didn't have a dependency for the version number where they changed the entire API around.
Okay, so that's an example of CPAN testers working correctly, because you got that failure, you realized there's a new version of graph.pm,
Right.
and then you could declare a dependency on that version. So that, I think, was a
Right,
legitimate
but that was
bug.
caught by someone who was not running a version install. That was caught by someone that had a really ancient version of it.
Yeah, so, that happens. So the question is also,
Right,
you know,
so I
right-
guess the question is, how do you find version dependencies if all you're testing with is versions?
So the way that this works, and this is the weakness of the system, is that dependencies are going to be installed as determined by CPAN-M. CPAN-M is basically going to look, if there's a version number specified, it's going to look at CPAN, see what the most recent thing is that satisfies that dependency. So that means that this system as it's built right now is only going to test against a point-in-time set of dependencies for your distribution. And that set can change over time, as you discovered. So you might have a downstream dependency, they release a new version that it ends up breaking your code. You won't get that feedback from this system unless you then release another version of your distribution to test it again. However, there is a feature that I would like to add where you can go in and press a button that will basically do this process over again, grabbing any new versions of dependencies. But that doesn't exist yet. Yeah.
From the beginning, I noticed that you're actually bucking this trend of Perl, which is that people think that you as the author are supposed to be responsible for including the dependencies appropriately with the right versions. Sorry. So that's okay. But maybe the answer to Walt's question is you send in one-time feedback saying, you know what, kind of like Perl critic, you declared dependency without a version. You want to make sure that you meant to do that.
I think that's a good thing for release management.
Right.
I think if you use something, like I'm a big fan of Distzilla, and I'm sure, I guarantee you there's a Distzilla plugin that will prevent you from releasing if you don't specify version numbers for your distribution. So there's a fuzzy line between, you know, what's release management and what's release testing and what's integration testing. All of those sorts of things come up. And
By the way, I'm not complaining about.
oh yeah,
doing it.
no, I understand. And it would be nice to test for all that stuff too, but you know, like
Perl itself has the problem of needing good programmers to write good code.
yeah,
You can't fake it, and you have to set your own constraints. I think that's the nature of CPAN testers as well, but
Yeah.
it's okay to make it better.
yeah. And again, you know, as I mentioned before, the goal here is not to replace CPAN testers. I like CPAN testers. If this is the goal here is to augment CPAN testers with something that works differently, so you can get more information about what's going on with your distributions.
Would you consider leaving the failed directories around? So, you know, if you got that failed test back, it might be nice to have that kind of state instead of just blowing it away.
That's a possibility. I don't do it now. What we do save is everything that comes out on standard error and everything that comes out from the tap. So in addition to that structured tap data, I also save the raw tap data as basically a chunk of text, so you can look at that as well. Saving the actual files again on taps and everything, I don't do that, but maybe that would be useful for a little while.
Are you still running it on EC2?
Oh, yeah, so that's a question. You know, so I mentioned throwing away prototypes. So the website that is built still runs on EC2, but the actual testing no longer runs on EC2. I actually have that running now on my beefy desktop Mac, which is sitting under my desk at home. And I have a Parallels installation, so I have I'm running them on OS 10, and I have a Linux running on Parallels. I think it's like Fedora Core, a couple versions old. And so that, and then sending the test results over HTTP. And I didn't show any of that in this presentation because I just built a lot of that stuff like a week ago.
Do you have a story for Windows?
What's that?
Do you have a story for Windows?
I'm sorry?
Do you have a story for doing Windows testing? Because you talked about it being one of the...
Yeah, that's one of the things I want to do. So one of my projects is I want to set up a second Parallels install with Windows OS. Install a bunch of probably Strawberry Perl or something like that in order to do it. So I haven't done any Perl programming on Windows in like 8 years. So I need to get up to speed with that. But yes, that would be the kind of the third prong of the project that I'd like to attack.
So one follow-up. So right now the code that you have on GitHub is really tightly coupled to the way that you happen to have that server installed, right?
Yes.
Okay.
Yes, it is. So right now, this is not really set up as a general consumption product. The separating the reporting stuff from the data stuff, as I'm doing now, by basically turning it into a web service, will make this something that you can install fairly easily internally and use inside organizations. I also, if you remember a few slides back when I was showing how I insert those distribution data into my MongoDB, I prefixed them all with the string CPAN. And the reason I did that was so that potentially if there are other people out there who want to test things that are released to their private CPANs and so forth, they can be in a separate namespace. None of that exists yet, but I was trying to future-proof it to think about what it would take in order to do that in the future. All right, well, thank you very much, guys.